This is lecture 31, and in this lecture we are going to solve some numerical problems based on the Laplace transform. Okay. So, let us take simplest example. Okay. If I want to talk about this impulse function. Okay. So, you know definition of the impulse function. So, this del of t equal to 1 for t equal to 0 and 0 for t is not equal to 0. That is the definition of this delta function. Now, if you want to calculate the Laplace transform of del t, okay, that is you can represent with the x as. So, 0 to infinity del t e to the power minus s t dt. Okay. And you know this integration of this e to the power minus s t, okay, del t. Now, this del t is only valid for t equal to 0 as per the definition of this impulse function. So, this means e to the power minus s t is only valid for t equal to 0. So, when you put t equal to 0 in this equation, you will get the value of this. So, the Laplace transform of del of t is equal to 1. You have to remember also, because in some numerical we are using this direct answer, okay, and that is for all s. Okay. So, for all s, if I want to design the ROC, okay. So, ROC is nothing else this is the j omega axis, this is delta क्योंकि and this is S plane. So, the ROC will be your all, or you can write it down, ROC is all S. सारी S के वैल्यू के लिए ये हमारा रीजन ऑफ कन्वर्जेंस होगा. Okay. Now, take quickly another example. If you want to take this unit step, okay. So, unit step, and the definition of unit step is means you are going to take x t equal to u t, and the definition of this unit step, all of you know that this is 1 for t greater than equal to 0 and 0 for t less than 0. So, if you want to calculate the Laplace transform of u t, okay, let us see, this is represented by x s. So, it will be nothing else because it is valid for t greater than equal to 0. So, we are taking the limit 0 to infinity over here, okay, and at this particular integration the value will be 1. So, ut will be 1 e to the power minus s t dt, or you can write it down in this way. Okay. So, this is nothing else when you integrate e to the power minus s t, it will be e to the power minus s t upon minus s and 0 to infinity. From here, obviously, you can take 1 by s outside, e to the power, put the value of limit e to the power minus infinity minus e to the power 0, that is nothing else 1 by s. Okay. And that is valid for when real part of s is greater than 0. Okay. So, ROC डिज़ाइन आप करना चाहते हैं, बनाना चाहते हैं, so that will be your ROC, j omega sigma s plane, this is 0. So, that will be your ROC, this portion right hand side, okay, that will be ROC sigma greater than 0. Okay. Sigma की value क्या है? Greater than 0. So, in this way you can calculate your Laplace transform. Okay. Just take one another example, so you will understand the concept of this Laplace transform. Let's see, given example ले लेते हैं, x t equal to e to the power a t u t, and you want to calculate the Laplace transform for this function. So, you know the definition, x s equal to, that is nothing else, the your Laplace transform of x t, that is your e to the power a t u t. Okay. Now, in this you can see over here this u t is mentioned. So, one thing is clear कि जो हमारा सिग्नल है that is integrating from 0 to infinity, ut means ut की definition add हो गई. So, ut will be 1 कब होगा, this value will be 1 when t greater than equal to 0. So, यहाँ से हमें एक लिमिट पता चल गई, that is integrating from 0 to infinity, not minus infinity to infinity, it is integrating from 0 to infinity. एक्स टी की वैल्यू दैट इज ई टू द पावर ए टी, यू टी की वैल्यू क्या हो गई आपकी 1 हो गई, एंड यू टू द पावर माइनस एस टी डी टी. सो दिस विल बी योर फाइनल इंटीग्रेशन पोर्शन, माइनस यू कैन टेक आउटसाइड, सो एस माइनस ए टी डी टी. नाउ यू हैव टू सॉल्व दिस, सो यू कैन easily write it down, that e to the power minus s minus a t upon minus s minus a, and limit is 0 to infinity. Okay. So, when you put e to the power minus infinity, okay, or directly you can write it down, that is 0 e to the power 0 1 upon s minus a. Okay, or you can write it down 1 upon s minus a, minus will be here. So, minus minus will cancel out. So, that will be minus 1 upon s minus a. Okay. Now, if you want to calculate the ROC for this, okay, this Laplace जो भी calculate हुआ, so this real part of s, or you can write it down sigma greater than 0. Okay. So, from here this portion of this s minus a should be greater than 0, or you can write it down real part of s should be greater than a. Okay. So, if you want to plot this ROC, so you can write it down, this, let us see, this is a is over here. Okay. So, this S plane j omega 0 sigma, this value is a. So, this ROC will lie here. Okay. A से ज़्यादा वैल्यू होनी. Okay. So, from here this real part of s minus a greater than equal to 0, or from here you can calculate this real part of s greater than a. So, e to the power a t u t का जो Laplace transform है that is 1 upon s minus a, and this is ROC is real part of s a greater than a. Clear? Now, same if the question it is given e to the power minus a t u t. So, for this Laplace transform is nothing else 1 upon s plus a. When you solve with the same process, you will get e to the power minus a t u t, इसका Laplace transform 1 upon s plus a, and ROC जो होगी उसकी just opposite होगी, that is your real part of s is greater than minus a. Okay. So, you have to remember also these, क्योंकि जब कभी न्यूमेरिकल्स आएंगे, ओके, उस सिचुएशन में अगर आपको ये डायरेक्टली याद रहेंगे कि e⁻80 ut का ये होता था, e⁻80 ut का हमारा जो लैप्लास होता था ये होता था। तो वहाँ पे जाके हमारे जो न्यूमेरिकल्स प्रॉब्लम हो वो इजी हो जाती हैं और टाइम हमारे पास जो हमें टाइम लगता है वो कम लगता है, क्योंकि वो आप डायरेक्टली इस क्वेश्चन में पुट कर सकते हैं वो वैल्यूज़। ओके, सो इन दिस वे यू कैन सॉल्व these numerical problems. In lecture notes you will find out the more numerical problems given, so you can refer these numerical problems. Thank you.